Hello friends, today we will see shear force diagram as well as bending moment diagram for a beam, and today we are going to see cantilever. So all of you know what is a cantilever. A cantilever is nothing but a beam fixed at one end and its one end is free. Let me draw another one for you. So we can just simply draw a line and give this is the symbol for fixed end, and this is the beam that is free at its one end. This is free, there is no support or no hinge, nothing is there, this is free, and at its one end this is fixed, so we call it cantilever. And this is the free end. Suppose a point load is acting at its free end and say of magnitude W. So we are going to draw shear force diagram and bending moment diagram for cantilever. The two diagrams are same. This is a cantilever. So how will you represent, or how you are going to determine bending moment across the length of the beam? Suppose L is the entire length of this cantilever beam, right? Let me denote the two ends as A. This is where the beam is fixed, I have denoted as A, and the free end I have given as B. So this is the entire length across which this load is acting, and as you can see at B the point load is acting, but in between this free end and fixed end there is no other load except besides W there is no other load. So we can understand that at this point or this point also W is acting, right? Because there is no other load in between. And now coming to bending moment. Bending moment in short we also write as B dot M. So bending moment is nothing but the moment of the force. Like this point load will try to bend this beam, right? Bend in the because this load is acting in the vertically downward direction. So this beam will also try to bend in this direction. So bending moment, this is nothing but the moment of the force. And you know how to find out moment is nothing but force into perpendicular distance, or the arm across which the force acts, right? So if we have to find out moment at A, bending moment at A, it will be nothing but minus W into L. And now let me give you sign convention for shear force and bending moment. Sign convention. So sign convention will be negative for downward direction. If a force is acting downward direction, so the shear force will be negative for force acting downward, and shear force will be positive for all the forces acting in the upward direction. Upward direction. So here we can see this W is acting in the downward direction. And now, so I can draw again. This is the fixed end and this is the beam. This is the length L and this is the free end at which point load is acting. So bending moment, so this support will take the entire load, because we can see in between there is no other support. Other than this there is no other support which can take W. So the entire load will come at this support. This entire W will be coming at this support. So the reaction, the counterweight, the counter load becomes the reaction, and that is nothing but W. This entire load will be taken by this support. So here this becomes a counterweight, or the reaction that is coming at the support is nothing but again W. And we know bending moment, just we have talked that bending moment is the moment of force. So moment of force is force into perpendicular distance, or the arm across which arm through which force acts. So if we have to calculate bending moment at B, this is the point B and this is the point A. Bending moment at point B is nothing but it is minus W into L, because just we have seen the sign convention for shear force. If the load is acting, force is acting in the downward direction, we take minus. Had it acted in the upward direction, the sign convention would have become positive. Suppose in place of this it would have acted like this at A vertically upward, so at that time we would have taken positive. Here this minus WL will act at B, so bending moment at B is minus WL. And if we have to find out bending moment, so now first see, let us take one section say x, and this is at a distance small x from free end, right? And here automatically, because we have started from free end and this is x, so this is nothing but here x is equal to 0. Suppose this is x is equal to 0, and here this is the distance x is equal to x, and at free end, this is understood that at free end the distance is x, because 0, because we have just started from the extreme end. There are two extreme ends, one is fixed and the other one is free. So bending moment, what we can write, bending moment at section xx, that is x is equal to x is equal to minus W into x, right? And how bending moment is varying? Bending moment is varying linearly as we are going farther from the free end. This is varying linearly. The magnitude would go on increasing as we progress farther from free end to fixed end, towards fixed end. So bending moment at section xx, which is at a distance small x from the free end, becomes minus wx. And bending, similarly we can write bending moment at point A, that is at the free end, is equal to minus, this is equal to 0. And at bending moment at B, point B, that is a fixed end, is equal to minus W into L, because here x is equal to L, we are taking the entire length. This support is going to take the entire load force, because in between there is no other force. So now we have just seen how to calculate bending moment at different points or different sections throughout across this length of the cantilever beam. So now we are in a position to draw the bending moment diagram. So what is going to be the bending moment diagram? We can draw a projection. This is the A fixed end, this is B, where point load is acting at the free end. This is the free end where point load is acting, we have taken B. So here this moment, let me draw one projection, right? Projection. So as how we have seen, bending moment is varying linearly. At point B, this is the point B and this is the point A. At point B bending moment was 0, and here as we are going farther gradually from fixed end to free into fixed end, this is increasing, varying linearly. So this bending moment, and this is negative, this is A, and at A this is minus WL, this is WL which is negative, and here it is 0. So this is varying from 0 to WL, varying from 0 to WL, bending moment variation from B to A, that is B to A is nothing but the entire length of the cantilever beam. So this is, so now talking about the shape of the bending moment diagram. So bending moment diagram of cantilever is nothing but is triangle. And how the conditions are: when a point load is acting at the free end and there is no other load like UDL, uniformly distributed, or there are other kinds of loads as well. So here just only one point load is acting, and also that is at the free end. In that case, bending moment diagram is triangle, and the variation is linear from free into, as we are progressing, going from free into towards fixed end. And now we are left with shear force diagram. So our objective was to find out the shear force and bending moment diagram for cantilever. So just now we have completed the how to draw bending moment diagram. So, and we have also seen how triangle is coming. So now we are left with shear force diagram. Let me draw a line where we can just draw this shear force diagram. So at point B, this is the minus W, because just we have seen the convention for force, if it is acting downward we take minus. So here W is acting, so W minus W, right? So W magnitude will, we can take a magnitude of W in the downward direction. And as we continue towards A, till fixed end, there is no other force. So at here also the same magnitude W is acting, here also this is W is acting, and at point A also this is the support that will also take the equal amount W, but in the opposite direction, because this is going to balance this beam, counter this load. So we can go in this direction. The same magnitude, this is the same magnitude, can be taken as W. This is the height is indicating the magnitude. So we can traverse like this, and we have to stop here because this is the projection, and now we can go up. So this is the shear force diagram, and this is also negative, and the magnitude is, this is length L, and the area is not, area of this is nothing but the height into length. Height is W and length is L, and this is nothing but the bending moment. WL is nothing but bending moment, and this is coming as we take the area of this projection is height into length, and this is WL, and this is the bending moment again. So we have drawn shear force diagram. Shear force diagram for a cantilever beam with point load acting at the free end becomes a rectangle, and bending moment diagram for a cantilever beam with point load acting at the free end becomes a triangle. And one important things you should know, shear force diagram always closes. As you have begun here, this will nowhere finish in between. This is going to end here only where the support is given, right? So you should remember this. So this is how we have just seen a simple case where all of you should be clear. In the next video we will learn about shear force diagram and bending moment diagram for a cantilever beam with uniformly distributed load, or two different kinds of loads are acting. Suppose one moment is also given in between. I hope things are clear for you, and anywhere if you find difficulty, just pause the video and watch again and again till you are clear in the concept. Thank you. We'll meet again.